Hello students, welcome to the online lecture series of St. Andrews Institute of Technology and Management Gurugram. Myself Satinder Vats, Assistant Professor in ETC Department. In today's lecture we will see some operations on the signals, which is a part of unit first of signals and systems. So we can have several operations on the signals like amplitude shifting, in which we can change the amplitude of the signal. Time shifting, that is using time shifting we can delay or advance our signal. Time reversal is a special case of time scaling, we will see how. Then we will see time scaling, in which the signal can be compressed or expanded in the time domain. And amplitude reversal, in which the amplitude of the signal would become negative. Okay, so let's start with the amplitude shifting and amplitude scaling. So it can be of two types, that is, if we can multiply the function by a constant value, then it will be amplitude scaling, and if we add or subtract some constant to our signal, then it will be the amplitude shifting, which can be of two types, that is downward shifting and upward shifting. So if we have our message signal or whatever signal we have xt, if we multiply it with a constant k, then the it would become a new signal yt, that is yt is equal to k into xt, and yt is a scaled version of xt. Similarly, if we can add some value to our system or subtract some constant value to our signal, then we will get a new signal, which is a amplitude shifted version of our original signal, that is xt. So let's understand it using an example. Here in this example we have xt, which is defined for the time range 1 to 2, and the amplitude is 2. It is a rectangular pulse which is defined for t greater than 1 and less than 3, having an amplitude of 2. So if I draw y1t, which is equal to 2 of xt, and y2t, which is equal to 3 plus xt. So this first case is a time scaled amplitude scaling example, that is 2 of xt. So the range will remain the same, that is from 1 to 3, but the amplitude of the signal has now been increased from 2 to 4. So it has become 2 into 2, that is 4. We have multiplied the amplitude by 2. So the amplitude of y1t would be 2 times of xt. In the second case, we have added 3 into xt, so it would become 3 plus xt. Like it was 0, the xt was 0 before 1, it was 0 for time t less than 1. So now as I have added 3, so it will be added in all the amplitude values. So for t less than 1, it would now become 3. 0 plus 3, that is 3. And for 1 to 3, this value, it would be 2 plus 3, that is 5. And again after t greater than 3, it was 0, so it would be 3 again, as 3 would be added into the signal xt. So it is an example of upward shifting, that is the whole signal has shifted upward. If it was like that, minus 3 plus xt, then the whole signal would have shifted downward 3 units. Okay, so this is an example of shifting, amplitude shifting, and this one is the example of amplitude scaling. So next is time shifting. We can get the signal advanced or delayed. We can make our signal advance or we can make it delayed by some unit, okay, by using the shifting in time domain. So if we add some constant value in time domain, that is uh, if xt now become x of t plus k, where k is a positive value, then x of t plus k will be a signal which is shifted leftward. It would be shifted leftward and the signal would be advanced. Okay, we will see using an example. Or if we subtract some constant value, that is if we subtract x of t minus k, that is if we subtract some value k which is a positive value, then the signal xt would be shifted rightward, that is it will be delayed by unit k. So this is how we can delay a signal, or we can advance it by adding or subtracting something in the time domain. Okay, so let's see the example. If we have xt is equal to which is a rectangular pulse divided for 1 to 3 and amplitude of 1. So if I need to draw xt minus 2, so as I have told you that if I subtract some value, positive value, then the function will shift rightward, that is it will be delayed. So our xt would shift 2 units, that is if it was 1 at t is equal to 1, so now 1 plus 1, this value will come at 3, t is equal to 3. Similarly, the value which was the value which we were getting at 3, now we would get at 3 plus 2, that is at 5. So this is how our signal shifted in the time domain. If I need to draw x of t plus 2, then the system will shift, or the signal will shift left side. So the value which I was getting at 1 now will be available at 1 minus 2, that is minus 1, and the value which I was getting at 3 will be available at 3 minus 2, that is t is equal to 1. So amplitude would remain same in time shifting. So this is how our system will shift right if I subtract some value, or if I add some value, then it will go leftward. So this is how shifting will take place. Next is time reversal. So it is a special case of time scaling which we will see after that. So time reversal function would be the mirror image of the original functions. So if I take this example in which xn is a discrete signal defined at the time instant of 2, 3, 4, 5 and 6, that is from 2 to 6. At 2 and 3 it is 1, at 4, 5 it is 2, and at 6 the amplitude is 3. So if I need to calculate the time reversal function, that is x of minus t, so I will simply get the mirror image, that is what I was getting at 2 will now be available at minus 2, and what I was getting at 3 now I will get at minus 3. Similarly, what I was getting at 4 I will get at minus 4. So you can see it will become a mirror image of the original function. So it will become the mirror image of our original function. Okay, so now in time scaling, let's say time scaling, if we multiply the variable t, that is if we have xt, and now I multiply this t with some constant, that is x of kt, value k, then the new function would be a compressed functions. So the new function will be compressed in time domain, it would get compressed if I multiply with a positive value k greater than 0, or if I multiply t with a value, if I multiply this t with a value k which is k less than 0, that is, oh sorry, less than 1, which is less than 1, so I will get a function which would be expanded, that is, it would be expanded in time domain, that is, the range of the signal will expand if I will multiply it with value k less than 1. Okay, so it would be I have written is there, it should be k greater than 1, that is, it should be k greater than 1, and here it should be k less than 1, it is written wrongly over there, so it should be k less than 1. If I multiply t with a value less than 1, okay, so the function would be expanded. If I multiply with the value k greater than 1, then it will be compressed, or we can say if I divide t by with a value greater than 1, k greater than 1, then it will be expanded. These are both the same thing. Okay, let's see now how. So in this example, if xt is a square pulse which is defined for time 1 to 3 with amplitude 2, okay, if I need to calculate x of 2t, so what I would do, I will, it would be compressed, so what I was getting at 1, now I will get it as 1 by 2, and what I was getting at 3, now I will get this value at 3 by 2. So the function would be, the amplitude remains same, but the function is available for half of the time range. In first case, that is in original xt, it was defined for 1 to 2, that is 1 to 3, that is for 2 seconds, as you can see, 2 seconds in this case. Now it is defined for 2 seconds in xt, and since we have compressed the signal by 2 unit, so it is defined for 1 second in x of 2t, that is from 1 by 2 to 3 by 2. Similarly, if I divide t by 2, x of t by 2, then the what I was getting at 1, I will get at 1 into 2, that is 2, and what I was getting at 3, now I will get up to 3 into 2, that is 6. So signal is expanded by 2 units. So it was, the range was for 2 seconds, now it has become 2 into 2, that is 4 seconds. So in this case, that is the expanded version, the signal is defined for 6 minus 2, that is 4 seconds. So this is how it is expanded in time domain. Amplitude would remain the same. Amplitude reversal. Now if I multiply our signal xt by minus 1, if I multiply our signal by minus 1, that is, it becomes minus of xt, so amplitude would reverse, that is, if it was our xt signal defined for minus 1 to 2, amplitude was 1. Now if I take minus xt, so amplitude would become minus 1, and the range would remain same, that is minus 1 to 2. So it comes below the x-axis or the time axis, so amplitude becomes minus 1. So this is how amplitude reversal will take place. Now let's see some examples. So example first is, in which we are given xt is a square pulse, rectangular pulse defined for minus 1 to 3 with a amplitude of 1. Minus 1 to 3, that is for 4 seconds. Oh sorry, 0, 4 seconds it is defined, minus 1 to 3 with a amplitude of 1. So we need to draw x of 2t plus 1. So these signals require two operations, that is time shifting and time scaling as well, because we can see 2 is multiplied and plus 1 is added. So first is like we can perform shifting, time shifting, and then time scaling. So if I perform time shifting, so xt would become, because we need to add 1 if we are performing time shifting first, so xt plus 1 would be this one, that is the signal would be shifted leftward. If something is added, then signal would be shifting leftward. So now the range becomes -2 to 2. Now if I perform scaling, that is multiply it by 2 unit, so it will get compressed. So what I was getting as -2, now I will get at -1, and what I was getting at 2, now I will get 2 by 2, that is 1. So our new signal x2t plus 1 can be this -1 to 1 with same amplitude. Second method is I can perform scaling first and then shifting. So if I perform scaling first, I was having xt. So if I perform scaling, that is x of 2t would become, that is the signal would compress. What I was getting at -1, I will get at minus 0.5, and what I was getting 3, I would get at 1.5. Now I perform shifting. So there is a one thing to understand, that I have I have written the function in this form, that is I have taken 2 outside the bracket, taken 2 common, so it becomes 2t plus 0.5, because in this 1 was added to 2t, but I need to add something to t only, so it would be added to t. So that is why I have taken 2 common, and 0.5 is now added to t. So there will be a shifting of 0.5 towards left side as 0.5 is added. So now what I was getting at 0.5, I will get at -1, and what I was getting at 1.5, I will get at 1.5 minus 0.5, that is 1. So the result would come out to be same in both the cases. We can perform any function, like we can perform shifting first and then scaling, or we can perform scaling first and then shifting. Now one more method is there, let's see that with another example. So in this example we are giving xt, which is defined for -3 to 6, and it is a combination of two straight lines, that is -3 to 0 this line, so it becomes 2 at 0, and from 0 to 6 it decreases from 2 to 0. So this is our function xt. I need to draw x of -2t plus 3. So in this function we have three operations, that is the time reversal, minus is there, time scaling, and time shifting. So this is one of the very best method to draw these type of graphs. So as we can see in xt, we are getting at -3 the value of xt is 0, at 0, that is x of 0, the value of xt is 2, and at 6, that is x of 6, the value of xt is again 0. So now I need to calculate yt, which is -2t plus 3, x of -2t plus 3. So yt is 0. Yt should be 0 when this time, that is -2t plus 3 is -3, as xt was 0 at -3. So yt would be 0 for -2t plus 3 when this -2t plus 3 is -3. So equating both these, I get t is equal to 3, that is yt would be 0 at t is equal to 3. Similarly xt was 2 at time 0, So yt would be 2 when minus 2t plus 3 would be 0. Okay, so I get t is equal to 1.5 and yt is 0 again at time 6. So yt is 0 for minus 2t plus 3 at 6, because now time is minus 2t plus 3 and xt was 0 when the time was 6. So yt will be 0 for minus 2t plus 3 is equal to 6. So t comes out to be minus 1.5. So using this we can say yt is 0 at t is equal to 3. So t is equal to 3, y is 0. Similarly, if yt is equal to 2, then t is 1.5. So yt is equal to 2 at t 1.5 and yt is again 0 for t minus 1.5, that is this value. So we can see in this graph the value which I was getting at minus 3 is now I am getting at 3. The value which I was getting at 6 I am now getting at 1.5 and the value I was getting at 0 I am getting at 1.5. So you can see in this function we have performed 3 operations, that is time shifting, time scaling, because the range of this signal was minus 3 to 6, that is 9 seconds, but range of this signal is minus 1.5 to 3, that is 4.5 second only. So it is compressed as it is multiplied by 2. Also this signal is the mirror image of this signal. It has reversed because the value I was getting as minus 3 is now come at 3 and what I was getting at 6 is now I am getting at minus, and it is shifted also. So this is how we can do these sort of questions using this method. I hope you understand. Thank you very much.